Hi class, this time we're going to be talking about systems development life cycle. So some objectives that I wanted to focus on are just kind of understanding this term. Systems developed life cycle is also referred to as SDLC. We're going to look at a couple different approaches of this lifestyle or life cycle and why is it important to healthcare. We know that interoperability is really important. When we were talking about HITECH Act and how it was securing and moving patient data so that we can all access it safely. So we're kind of going to look into like the technical part of that this week. And then we're going to reflect on how it'll improve future systems and how that's going to involve us. So it's important to know the bare bones, the framework, just like in the ethics topic, and how that makes us not have to start from scratch. So we have these systems in place to help benefit mostly our patient and care. So a little brief introduction. SDLC is just a way that we can be more efficient. We want to be effective with our information systems, and we want to make sure that it fits with our plan. So a strategic business plan is important for any organization. So when we're looking at healthcare informatics, they also have within hospital systems business plan. So those allow for organizations to really set goals and to plan for how well they evolve or implement like day-to-day actions, operations, or what are their just main priorities. So the SDLC, it can occur within an organization. So they could have a task force related to that. It could be outsourced. So we can have a third-party involvement, or it can be a blending of the two where we reach out to a third party, but also internally organize some systems. So examples that we can look at is, one of them is like an older example. It's called a waterfall model. And it's really, you look at it and you're like, oh yeah, it does look like a waterfall, how it goes down step by step by step. So we know it's one of the oldest models. We know it looks like a waterfall, but what really does it entail? So each one of these steps, as you can see, has to be completed. So each phase kind of flows into the next one. So the first phase of any type of model where we're looking at changing something or improving a process, we have to require data collection. We have to look at, is this project feasible? So we have a feasibility study. We kind of bring in the design. The techie stuff is the coding and programming. We test it and we install it, and then we maintain it. So this one is very straightforward. This waterfall model, it's used in a linear formation, but examples might be something that is not going to change very often. So like a human resource management, or something that is structured where the technology isn't too complicated. So this is where a waterfall model would come into play. Now, some pros of it: it was a good model for when the technology was understood. But as we're getting more advanced systems, new softwares, it can get a little bit tricky. Some not so positive, so cons. It didn't have a lot of user input. So, I mean, it just went from one step to the next, and we didn't have a lot of that discussion and work through some of these processes. So if you got down to the installation and it didn't work right, you had to go all the way back up to the top and start over again. So time consuming, costly. It was really just meant for structured, stable projects like small implementations. So that's just one structure that we would basically use to form many other structures that are more commonly used. So let's go to another one. We have the rapid prototyping or rapid application development. So this one, it speaks for its name. It's a little bit quicker versus the waterfall. And it's kind of formed from the waterfall, but it's a little bit different approach. So it provides that fast way to add functionality throughout prototyping. So think of the prototyping as like a mini test. You're testing it out. The user is testing it before it's actually implemented. So it kind of gives you a little bit more feedback. This is like a quicker form of gathering information. We can do some workshops, some focus groups to build these prototypes. And then we're using that real data. And then you might have heard of something kind of like a beta page or beta testing. So this allows really that great feedback so that we can make sure it's functional for the individual. So again, you see this pattern. We'll see analysis and quick design. So we're building, we're demonstrating, we're refining. This prototype can go in circles as we're refining and making it more functional. We do some testing and then it's implemented. So again, a great one. Yep, just for quick projects, I guess. I don't think I have anything more to really add to that. So another one, we're just going to go through lots of examples. Object-oriented system development. So this one uses objects that are already existing to kind of improve. So we have modeling that's occurring. So we're looking at real world objects, modeling things. So like we have hospital sections, different patient types, different accounts, respiratory. We're using all these software objects and just improving on them. So you'll have different phases of this one. So we have that orientated analysis at the beginning. And then you see the object model. We have a dynamic model where we're getting more feedback in the functional models as they all interplay. Then we go into the design and then coding, like all the techie stuff behind that. So once the system is object oriented, all the interactions or exchanges take place between or amongst these objects. So that's how they can test it out. Let's go to another one. Dynamic system development. Well, this one also in the name dynamic means that it has a lot of user input, a lot of involvement. So we have 3 phases mostly, so it's very interactive. We have the pre-project phase. And then you have the life cycle in the middle. So the life cycle kind of has 5 different phases. Is it feasible? When we build that foundation, we go into the functional mode, the design and building, the deployment, we're still getting more feedback going back and forth. And then finally we get to that post project. So this really allows buy-in. So we have that first phase, the buy-in phase right here, pre-project. That's really telling you who your stakeholders are and getting that user input there. As we get into the project life cycle, we see the feasibility and business kind of build on each other. So we first want to make sure it's feasible, and then the business study kind of incorporates and examines, extends the process for stakeholders and their needs. So it kind of goes in a little bit deeper. And then after you get through the 5 steps, we verify that the system is functioning properly in that post project. So another great way to kind of implement a model in that decision-making process. So some tools along the way. So we have system development models. We have software development models. and we have software to help software get refined and developed. So I'm not a pro at all this, but this is, if you look up computer aided software engineering tools, those are really tools that help the entire process. So they used to be very costly. And as they refined them, they're now more useful. So it really allows more automation of tasks. So if we were doing a lot of tasks physically or paper format, this really allows us to reach patients more effectively, efficiently. Some examples for automation. So you might see like chat boxes or bots, so robotic chat functions, scanning files, just getting everything online so it's readable, scheduling appointments. Those are things that took a lot of task time for us in the past, and now it's pretty much automated. Patients can schedule their own appointments. And patient tracking information. So we're using our systems and we're using software to improve software systems. Pretty cool. So some of the case tools, so computer aided software engineering tools, they use this process of planning, analyzing, design. They could also use implementation, testing, and maintenance, or a combination of both. So we might see the uppercase and the lowercase kind of working hand in hand. So we know these tools help reduce costs and kind of enrich the software product itself. So we all need a little helper for all this. At the end of this, we're enriching that quality of the product and really making sure that it's defect free at that point. So that's part of that testing and maintenance phase too. Open source software. So you're going to see some of this language, OSS. Any programmer kind of understands this, and it might be a little bit harder for an intro class like this to understand, but think of the open software as something that is free and programmable. So we can modify it, we can apply it, we can restructure it. We can use it to restructure our rich libraries of source codes. So when you're looking at source codes, think of this HTML source. I know sometimes I hit the wrong button and all this pops up, but it really tells us what each one of these commands are doing. So everything has a name or content or a list of algorithms that kind of text or command our software to do what we want it to do. So I just pulled up some basic programming software here. So we have basic Java, JavaScript, C, Python. Those are pretty common ones. And then also with the open source, the number one open source software that is used in healthcare is actually Firefox, the Mozilla. So it acts as a web browser. So we're not saying all web browsers are open source or highly used, but this one was number one, and it had multiple plugins. So multiple things that you could click on from just one page. So kind of cool how that's all programmed in for that user accessibility. When we're looking at interoperability, again, from the ability to share information across organizations, we really know that that was an important part of the HITECH Act from 2009. And it's built upon that time. We wanted to focus on the ability to share patient data. It's very extremely important within an organization and their boundaries. So best thing is that interoperability allows for timely and secure access of any electronic health record data. So a lot of times we might be seeing healthcare systems working with vendors. So this is just one way that they are using interoperability to partner and enrich their systems, but also make sure that they're still secure. So there's a nice article here on interoperability and vendors that you can read. And I just wanted to kind of show another example of how it's affecting the data platform, how it's connecting to all these entities. So really HITECH Act allowed for all this to occur. So just in summary, we know that the SDLC, there's new information, it affects how phases are developed and re-examined. So why do projects halt? Why are there sometimes a lot of ideas that just don't get utilized? So how can we process those results? And then we have team leaders that preserve these ideas so that they can be considered at a later time. So I think the big part of this is making sure that we have input from our stakeholders, that we're making systems that are efficient and they're going to be helping us with our patient care needs too. So that exchange is so important. And then as technology and research continue to advance, we know that our models might have to adjust and enhance some of these techniques. And then the interpretation and implementation of any of these models selected reflects the knowledge and skills of the team applying the model. So again, we're using the model to benefit, to make it more efficient, and to get to that goal or that strategic plan. So meeting our day-to-day operations and so much more. So I'm hoping that this brief cycle development kind of allows you to see that things aren't just thrown in to healthcare, that there's a lot of systematic ways that we're looking and analyzing and improving our processes. So a lot of the background or behind the scenes stuff that's also going on, which I find it's very exciting, a little bit daunting to know that there's so much behind all that, but what is our part in it? While we want to be active and dynamic in all these stages from early on to the very end, making sure that our input is valued, as well as making sure that it fits. You know, we'd hate to use a system that doesn't work for anybody or doesn't give us the right data that we need. So, and that plays into our workflow. So we had that video also posted on Moodle. So take a look at that and be posting your next assignment for our group activity.